In section 6.2, you're going to be multiplying polynomials and using Pascal's triangle to expand binomials. So let's start out by multiplying a monomial by a polynomial. And in order to multiply a polynomial by a monomial, you'll need to use the distributive property and the properties of exponents. So let's find the product of a monomial and a polynomial. And basically what you do is just distribute. So you're going to multiply the numbers and you're going to add the exponents. Now remember that when you don't see an exponent on a variable, it's automatically understood it's c to the first power, or the variable to the first power. It's not to the 0 power. So here we're going to add 1 and 2, and here we're on the c, and here we'll add 2 and 1 on the variable for d. And then you just continue distributing. So when we multiply this, we're going to get 12c cubed d cubed, and here we'll get negative. Now remember to take the sign with the number when you're multiplying. So this is going to be negative 18, and again this is going to be c to the first power. So we have c squared. D squared times d to the first power is just going to be d cubed when we add the exponents, and then we'll multiply the 3 and the 14 to get 42. C times c is c squared, and then d squared times d squared is d to the fourth. Okay, there's one on the right for you to try, so you can turn off the video, try that, and then turn it back on. Now we're going to multiply a polynomial by a polynomial. So we're going to have more than one term that we're multiplying by. Here we have a trinomial, because there's 3 terms, multiplied by a trinomial. So what you want to do is you want to take the first term in the first trinomial and multiply it by all 3 terms in the second polynomial. And what I'm going to do is I'm going to line up like terms as I multiply. That way when I'm finished I can just add down the columns. So x squared times x squared is x to the fourth. X squared times 5x is going to be 5x cubed. And x squared, again, take the sign with the number. X squared times negative 2 is going to be negative 2x squared. Then I'll go and multiply the 4x, or the minus 4x, I should say. So we're going to multiply negative 4x times x squared, and then negative 4x times 5x to give us minus 20x squared, and negative 4x times negative 2, so a negative and a negative will turn to a positive 8x. All right, now we've multiplied through by the x squared, by the minus 4x, and now we have to multiply through by 1. So that's just going to give us that second polynomial. So x squared plus 5x minus 2. And again, I'm lining them up with like terms, so now that I've done that, I can just add down the column. So I'll drop down the x to the fourth. That's going to give me a positive x cubed. This is going to be a negative 22x squared, and then when I add a x squared, I'll get a negative 21x squared. Adding here, I have 13x squared, and then this is just a minus 2. Now we're going to use Pascal's triangle. Well, again, you have one off to the right there that you can try, so turn off the video and then go ahead and try that problem. Okay, now we're going to multiply a binomial. And a binomial has 2 terms, and we're going to multiply a binomial, or raise a binomial to a power. And that's the only time that you can use Pascal's triangle to expand binomial expressions. Binomial expansion is a quicker way of expanding or multiplying out a binomial expression that has been raised to a very large or larger power. So if you have squared, then it might just be faster to square the polynomial out. But let's try a binomial that has been cubed. Now, just a reminder here, I still see some people trying to cube individual terms. When you expand this, that actually means multiply this by itself 3 times. So you have to write that out and multiply. So here we'd have to multiply these, or FOIL, and then we have to simplify that and then multiply it by the 3rd term. Now that's not too bad, but when you get to the 4th and 5th terms, it can get quite tedious, or 4th and 5th power and higher. So when you expand Pascal's triangle, when you use Pascal's triangle to expand a binomial, only going to need 3 rows to set up your problem. And it doesn't matter what the exponent on your binomial is. Each problem only requires 3 rows. So let's get started with Pascal's triangle. First, you need to know how to create Pascal's triangle. So the first row is always row 0 because it's always the row number is always the exponent that is on the binomial. So this would be row 1 and row 2 and so on. Now you always start out with 1. And then the next row is 1, 1. Now after you write those first 2 rows, then you just take the 2 numbers, add them together on a diagonal, and that will give you the number that's below them diagonally. Now in addition to that, every row starts and ends with 1. So let's just go down here first. And the first row is row 0. First and last number in each row is 1. The second number in the row is the exponent. So if you look at this one right here, you have an exponent of 2, and the second number in the row is 2. Exponent is 3, second number in the row is 3, and so on. Each number in the row is generated by adding the 2 numbers diagonally above it. So that's what I was saying just a few seconds before here. You're going to take these 2 numbers, add them together, and you'll get the 2. So first and last numbers are 1 in all of the rows, and then you fill in the rest of the row by going to the previous row and adding the 2 numbers diagonally above. So here we have 3, 3. 1 and 3 is 4, 3 and 3 is 6, 3 and 1 is 4. Same thing here. 1 and 4 is 5, 4 and 6, 10, 6 and 4, 10, and 4 and 1 is 5. So we are going to find the numbers in row 6 of Pascal's triangle. So if we wanted row 6, we would put the first and the last numbers as 1, add those together to get 6, 15, 20, 15, and 6. Now Pascal's triangle, every row in Pascal's triangle is a palindrome, which means it reads the same way left to right as right to left. So if I would split this in half, 1, 6, 15, so we'll go 1, 6, 15, 20. So that's like mom or dad. They read the same right to left or left to right as they do right to left. Okay, so now we're going to use this to find the numbers in row 6. We found the numbers in row 6, sorry, and here they are, and we just talked about that they're a palindrome, so they read the same left to right as they do right to left. All right, now we're going to expand this binomial by using Pascal's triangle. So here are the steps that you need to follow. You need the numbers in row 3 of Pascal's triangle. So these are the 3 rows that I'm talking about. This is your setup. The first row is going to be, you look at the exponent, and that tells you what row to go to. So when we go to row 3, back up here, we use 1, 3, 3, 1. The second, or the next row, is the first term raised to the 3rd power. And we raise it to the 3rd power because we take the exponent and then we decrease it by 1. So when we take 6m and we cube that, we're going to get 216 m cubed. And then when we take 6m and square it, we get 36m squared. And then to the first power, that's just going to be 6m. Anything to the 0 power is just 1, not 0. Okay, so this is the number that we're going to be using. Just going to circle it so it pops out a little bit. Then in the 3rd row, we take the second term, which is 8, negative 8. And again, make sure you take the sign with the number. And we raise this one to the 0 power, and then we go up by 1. So here we have negative 8 to the 0 power, which is going to be 1. Negative 8 to the first power, which is going to be negative 8. And negative 8 squared, which will give us 64. And then negative 8 cubed, which is going to give us negative 512. Okay, so here are the numbers that we have simplified. And then the last step for Pascal's triangle is we just need to multiply down the rows. So when we do that, we'll multiply down here, and we'll get 216 m cubed, and here minus 864m squared, and multiplying. And remember, you need to multiply. I'm going to circle this one up here because sometimes students forget to multiply this one. So you're always multiplying three things together when you're doing the multiplication down the columns. So 1, 1, and minus 512 will give us a minus 512. All right, now I'd like you to try the next one on your own.